So what kinds of questions might you be asked about linear independence? Well, the most common natural example is, here's a set of vectors. Is this linearly independent? So let's take a look at an example of this type. So let's take our set of vectors to be, we'll take v1 to be 1, 1, negative 3, and v2 to be 0, 1, 1, and v3 to be minus 3, 1, 13, just to make life interesting. Okay, so then the question is S independent? All right, well, so this is the same thing as saying, hey, can we have a non-trivial solution to this equation, right? And so we're looking for non-trivial solutions to the homogeneous equation. So now we're back in familiar territory. Okay, so let's take the matrix that we find by putting in the column vectors, by putting in these vectors as columns. So we form that matrix and say, okay, so this is going to be 1, 1, minus 3, 0, 1, 1, negative 3, 1, 13. So we're thinking of this as the coefficient matrix of this linear system here. And then we row reduce to figure out if there's non-trivial solutions. And so when we row reduce this one, we get 1, 0, negative 3, 0, 1, 4, 0, 0, 0. And I'll leave that up to you to do the row operations. From this, we see we have pivots for x1 and C1 and C2. And so then we have C3 is free. So let's let C3 be some free parameter t. Okay, so then these as equations say that C1 minus 3C3 equals 0, and C2 plus 4C3 equals 0, and then we're going to let C3 be equal to t. So we have C1 is equal to 3t, and C2 is equal to minus 4t, and C3 is equal to t. So that tells us then that if we take 3t times our first vector and minus 4t times our second vector and t times our third vector, we'll get 0. And that works for any t. So not only did we find a non-trivial solution, but we found an entire one-parameter family of non-trivial solutions because we can take t to be any value. So if we take t to be 1, for instance, then this tells us that, for example, minus 3, 1, 3 is equal to minus 3 times 1, 1, minus 3 plus 4 times 0, 1, 1. And so there we have a dependency relation. Okay. Now, notice that since this is a 3x3 example, and it is all about determining whether or not we have non-trivial solutions to a homogeneous equation where the coefficient matrix is square, we could have used the determinant instead. So for a shortcut, so this is for a square system, we could have done 1, 1, minus 3, 0, 1, 1, minus 3, 1, 13, taken the determinant, and so this is 13 plus 0 plus negative 3 minus 9 minus 1 equals 0. Okay. So what about in a non-square situation? What do things look like? Let me do one more example. So if we take S to be, let's take V1 to be minus 2, 2, 3, 2, and V2 to be 2, 4, negative 2, 3, and V3 to be 6, 6, minus 7, 4. Okay, so then the question is S independent? Whoops. Okay, so now in this case, the determinant is not available to us because we're looking at a non-square system. But the basic question is still the same, and that is that if we look at this matrix with columns given by the vectors that we have here, what happens when we row reduce this? So when we do that, we end up with 1, 0, 0, 0, 0, 1, 0, 0, and minus 1, 2, 0, 0. So looking at this guy, we have 2 pivots, but we have a total of 3 variables, C1, C2, C3, 1 for each column. So we're going to have 1 free parameter. So that free parameter then is going to give us a dependence relation. And so we know that S is going to be a dependent set. Now, if I had taken the same example here, and let's just replace this 6 here with a 5. Okay, then if I look at the matrix formed by throwing in those vectors as columns, and I row reduce it, I end up with 1, 0, 0, 0, 1, 0, 0, 0, 0, 0, 0, 1, 0, 0, 0. Now, in this case, we have 3 pivots. And so we have still 3 total variables. And so we get no free variables. And so, in fact, if you reinterpret what this final matrix right here is saying about the world, that's giving you the coefficients for solving the homogeneous equation. So in other words, it's telling you C1 is equal to 0, C2 is equal to 0, and C3 is equal to 0. And so that's exactly the meaning of linearly independent. Whenever the homogeneous system only has the trivial solution. So in this case, S is independent.